Hello and welcome to another lovely edition of the program Teaching and Learning on Radio. Teaching and Learning on Radio is a program that comes your way every weekday on Prestige FM and some other radio stations. And it's brought to you by the Ministry of Education right here in Niger State. We have lots of subjects that we treat every week, every day of the week. We always try to see how we can give the students at home another opportunity to learn while they are home. You know, the pandemic is everywhere. The coronavirus pandemic is everywhere. And so the shutdown and the closure of schools and companies actually made the students are at home right now. Those preparing for WAEC, NECO, and other examinations, I think it's an opportunity for them to stay at home and learn while listening to radio. The teachers, the facilitators will be right here in the studio with us. They will tell us about a particular subject. They look at a subject and a topic, and the phone line will be open for you to actually call in or probably send a message and ask your questions, and you will definitely learn something. So, well, it's for students at home, and it's brought to you by the Ministry of Education right here in Niger State. Teaching and Learning on Radio. Teaching and Learning on Radio it is. Well, today we have lots of things to learn, and we have our facilitator in the studio. You're welcome.
Listeners at home, you are welcome to a radio learning program organized by the Niger State Ministry of Education. I am here today to refresh your memory on what you have already learned in chemistry as volumetric analysis. The chemistry examination at the school certificate level is usually staggered over 3 papers. Paper 1 is objective test of 50 questions for 50 marks. Paper 2 is a theory paper in which students are required to answer 4 questions out of 6 for 100 marks. Paper 3 is a practical paper of 50 marks. Question 1 of this practical paper is usually volumetric analysis, in which every student will be expected to independently carry out an acid-base titration. At the end of this lesson, students should be able to 1. Define volumetric analysis. 2. Demonstrate how to carry out a simple acid-base titration. 3. Construct a table of values. 4. Calculate the average volume of acid used. 5. Attempt simple acid-base calculations. 6. List the precautions necessary in an acid-base titration. Now back to the topic, volumetric analysis. This is an analytical procedure to determine the volume of acid required to neutralize a stated volume of base. The materials needed for this experiment include a burette of capacity 50 cubic centimeter, a pipette of capacity 25 cubic centimeter, a retort stand with clamp, 2 beakers labeled A and B, where A is acid and B is base, a white tile, a filter funnel, a conical flask, and an indicator. To start the experiment, the burette is usually tightly clamped to the retort stand. The acid is introduced into the burette with a funnel and filled to the 0 mark of the burette. The base is introduced into the conical flask using a pipette. 2 drops of methyl orange indicator are added into the conical flask, and this changes the color of the solution to yellow. A white tile is placed underneath the conical flask. This will help in the identification of a color change. The titration begins by gradually introducing the acid into the conical flask using the right hand and using the left hand to shake the contents of the conical flask. This procedure is continued until the solution in the conical flask turns orange, which marks the end point of the titration. This is the point where the acid is completely neutralized by the base. The volume of acid used is then recorded in the table of values in 2 decimal places. This is to make for accuracy of the results. The content of the conical flask is discarded in a sink. The flask is then rinsed with distilled water and the burette refilled with the acid to the 0 mark. The process is then repeated 3 more times to make a total of 4 titrations, including the rough titration. The average of any 2 or 3 concordant titer values is evaluated. Concordant values are values that do not differ by more than plus or minus 0.20 cubic centimeter. Simple calculations are then made using the average titer value. Let us use 3 examples to illustrate. Example 1. A is a 0.125 mole per dm cubed of H2SO4. B is a solution containing X grams per dm cubed of sodium hydroxide. A. Put A into the burette and titrate it against 20.0 cubic centimeter or 25.0 cubic centimeter portions of B using methyl orange as indicator. Tabulate your burette readings and calculate the average volume of A used. The equation for the reaction involved in the titration is sodium. I'll write the chemical equation on the board. Sodium hydroxide plus H2SO4 to give us Na2SO4 plus water, liquid water. 2 moles of sodium hydroxide reacting with 1 mole of tetroxysulfate 6 acid to give us sodium tetroxysulfate 6 and water. From your results and information provided above, calculate the 1. Amount of H2SO4 in the average volume of A used. 2. Concentration of B in mole per dm cube. And 3. Value of X. Then we are given atomic masses in a square bracket. Capital letter H denotes hydrogen equal to 1.0. O equal to, that's O stands for oxygen, equal to 16.0. And Na stands for sodium, equal to 23.0, bracket closes. Now, specimen result of this example is shown on the whiteboard here. The titration is repeated 4 times, including the rough. Just as we have said, you have rough, you have 1, 2, and 3 titrations. Now, if you look at the table, there are certain essential ingredients that the table must have. There must be a unit, and the unit of volume is cubic centimeter. The values must be placed in 2 decimal places to make for accuracy. And of course, the values must be written clearly and not mutilated, because mutilation of values can lead to loss of marks in the exam. And then final burette reading is clearly written. Initial burette reading is indicated. Then the volume of acid used is also indicated. Then if we look at the first titration, that's the rough titer. Usually in the exam, when students are asked to do this experiment, the first titration is not always very reliable because of phobia, that's fear for examination. So the candidate may not be very composed to do the work. And so that's why we say that one should start, it should be the rough. And if you look at what we have here, you discover that even the rough is looking a bit divergent from other values. So his rough titer here was 26.5. His initial Binet reading was 0.00. And when you subtract, you have 26.50. Okay, the first titer value there is 25.5. And when you subtract from the initial one, 0.00, you have 25.50. The second one is 25.40. When you subtract from the initial 0.00, it is 25.40. The last one is 25.30. When you subtract, you have 25.30. If you look at the values, if you discover that titer values 1, 2, and 3 are very close to each other, while that of the rough is a bit divergent. And that is exactly what it is in practice. So the candidates will now, of course, you know, at any given time, it is the same acid and the same base that is titrated. And so there's no reason why the value should be so much divergent. So, and at the end of the day, the candidate will now calculate his average volume of acid used. And I want to also emphasize here that it is on this table that candidates are properly rewarded, because this is where the skill of the practical is shown. The other areas are just mathematical. We don't give so much marks in the mathematical aspect. But here, the candidate has used his hands, his eye, his all his instincts to do the work. So he's properly rewarded here. And of course, the candidates themselves do not even know this. So candidates, listeners at home, it's very important for you to know that half of the marks allocated for question 1 will be end on this table. So you must make sure that your table is properly, the values are properly verified. Of course, the teacher of a particular center usually submits his own value too, because when the candidates are asked to start, the teacher too also starts his own experiment, because the value of that teacher's experiment will be used to mark his own students. That's how the marking goes. So we expect that the students and their teacher will have, you know, values that are close to each other, because they use the same acid, the same base, under the same experimental condition. And so we use the teacher's value to mark those of the students. And as the value of the student is deviating from the teacher's value, the student will be losing marks. But as it gets closer, he will earn marks. Normally, a good value will earn 4 marks. So if a candidate's value did not differ from his teacher's value by within the range plus or minus 0.15, the candidate will earn 4 marks. But as it deviates up to 0.40, where he gets only 1 mark, anything greater than 0.4, he will get nothing. So on the table here, a candidate can get as much as 8 marks. This is very important for candidates to know that their mark, the bulk of the mark is on this table. Then if you look at, and candidates should ensure that values are not unnecessarily mutilated. They are not unnecessarily cancelled, because cancellation of values will also lead to loss of marks at the end of the day. Then all the values are shown in 2 decimal places, and then the averaging now. If you look at the averaging, we have averaged titer 1, 2, and 3 are said to be concordant. And by this I mean that they didn't differ by more than plus or minus 0.20 cubic centimeter, which is the standard used for the average. So in this case now, the candidate is at liberty to decide which values he can use for averaging. He can decide to use all the 3 if he likes, or any 2, because all the 3 values are concordant, meaning none of them differ by more than plus or minus 0.2. So this was a very good experiment that the candidate carried out. And so maybe in this case, he just decided to use first and second, okay? And that will give him 25.50 plus 25.40 divided by 2. So he now gets 25.45 cubic centimeter. The candidate will be rewarded for even this averaging. The mark on the table is independent of the mark on the averaging. A candidate may score 0 on the table, but can still score for averaging, as long as the values used are concordant. Punishment is not carried over all the time. You might be punished for not being accurate here, but as long as those values as you use in getting your average are concordant, the candidate definitely will score his marks. So when the values are concordant, you will get 1 mark. When they are properly evaluated by dividing with 2 there to get 25.45, he gets cubic centimeter, he gets another 1 mark. So averaging 2 marks altogether, then table 8 marks, making a total of 10 marks out of maybe 19 or 20 for the question 1. Now the next thing now will be some little calculations that go with volumetric analysis. These calculations are not usually very difficult, just merely arithmetical. The first one was calculate the amount of acid used. Amount of acid is usually equal to amount amount is denoted with small letter n and is usually equal to CV, where C is molar concentration of the acid measured in mole per dm cubed, and V is volume of acid used. Okay. So amount N is equal to CV. So the candidate's C was 0.125 multiplied by his volume of acid. This V is the average volume of acid, which is this one, which has to be converted to dm cubed by dividing with 1000, because 1000 cubic centimeter is equal to 1 dm cubed. So in that case, the candidate will divide 25.45 divided by 1000. He has converted it to dm cubed. So when you multiply all together, you have 0.318 mole. Amount is measured in mole. So the candidate gets his value as 0.00318. And I have to mention here too that this final answer now is in 3 significant figures, because in chemistry we expect all students at all times to give us their answer in 3 figures. And that is what we have seen here. A significant figure starts from the first non-zero digit after the decimal point. So these 2 zeros are not counted. You start counting from 3. This is 1, 2, 3. 0.00318 mole. That's the first answer he was asked to calculate. The second one is a molar concentration of the base. That's his CB. There is a popular formula that is used to calculate molar concentration. That formula is every candidate is expected to know this formula. Ca Va over Cb Vb is equal to mole ratio. So now Ca is molar concentration of the acid measured in mole per dm cube. Va is this volume here, average volume of the acid, which the candidate has evaluated from his table. Cb is the one he's looking for. And then Vb is the volume of his base, which is the volume of the pipette. There are 2 types of pipette, 20, 25, but most schools have 25, so we always prefer 25. So then Na is number of moles of the acid that reacted. From the chemical equation we wrote earlier, we discovered that 1 mole of the acid reacted and 2 moles of the base reacted. So if you look at what we are looking at this formula now, if you begin to substitute, you will have Ca was given to the candidate as 0.125 times his Va. Look at his Va here, 25.45 all over his Cb. That's the one he's looking for. Vb is 25. Mole ratio, acid 1, base 2. You can see how the mathematics is going. And this is how marks are also end. He will score for his mole ratio. He will score for substitution. The next thing is the subject or formula. He makes Cb, which is the one he's looking for, the subject or the formula, which will give him 0.125 times 25.45 times 2 all over 25 times 1. This is the third stage of the calculation. We have mole ratio, substitution, subject or formula. Of course, the final answer will now is going to be, his final answer is going to be 0.255 mole per dm cubed. If a candidate must use a unit, it must be properly, the unit must be properly used, because an answer with a wrong unit will not be marked. So the unit here is mole per dm cube. That is the value for molar concentration of the base, which he was asked to calculate. The last one is the value of X. If you look at the question, X was given in gram per dm cube. That means X is mass concentration. And of course, mass concentration is simply molar concentration multiplied by molar mass. So in that case, we will simply multiply. So X will just be equal to molar concentration, which is this one, 0.255, multiplied by the molar mass of the base. Of course, the base is a sodium triisocarbonate 4. If you calculate the molar mass, there are 2 atoms of sodium. So 2 times 23 plus atomic mass of carbon is 12 plus 16 times 3. You evaluate, you get 46 plus 12 plus 48. This will give you 106 gram per mole. Unit of molar mass is gram per mole, meaning that 1 mole of the carbonate, sodium carbonate 4, will weigh 106 grams. So if you now go back to the formula here, X, which is measured in gram per day, which is what we are looking for, 0.255 multiplied by 106, because the molar mass is 106. This will now give you the final answer, which is 10.2 gram per dn cube. So this is the final answer, measured in 3 significant figures. So that one, that is exact. That's let me quickly take another example, but that example will be taken from here. This is 24.60, 23.5, 47.00, and this is 23.45. Okay, this one is 0.00. This is 0.0. This is 23.5, and this one is 0.0. So in this particular case, so this is 24.0, 23.5, 23.5, 23.45. This is another example, example 2. In this example 2, a table was drawn like this, and the candidate was asked to identify any 3 errors in this table. A table was drawn like this, he was asked to identify any 3 errors. If you look at the table, the first error there is that there was no unit indicated. There was no unit indicated, so this is the one I had earlier. The table had no unit. And then there was an arithmetical error in the rough title. When he subtracted this from this, you can see what he had, 24.0 instead of 24.6. Arithmetical error is there. All the Birret readings were not taken to 2 decimal places. Okay, so that is that. Now, to calculate the average theta, he can average any 2 values. He can average this and this. Average theta will be 23.5 plus 23.5 divided by 2. This will give him 23.50 cubic centimeter. So he was asked to calculate the average theta here. So you can see he can pick any of the values, because all the this one and that one there, they are all concordant. So he can pick any to calculate his average theta. So now, precautions that are normally taken in an acid-base titration. These precautions include wash your burette with distilled water and rinse with the acid. Wash your pipette with distilled water and rinse with the base. Take your burette readings from the lower meniscus. That means you are going to avoid error of parallax. Because if you look at the normal shape of the volume in the burette is parabolic, like a curve. So you read at the bottom of that curve. That's what we mean by take your burette from the lower meniscus. Take your pipette reading from the lower meniscus to remove funnel from the burette before you start titration. Avoid air bubbles, either in the burette or in the pipette. Sometimes the candidates, when they want to transfer, they will use the amount to blow. Blowing is not allowed. Then put on a personal protective equipment, always, like hand gloves, goggles, laboratory coats, and so on. So in summary, we have tried to evaluate, we defined volumetric analysis. We tried to show how it can be carried out. We tried to show how a table can be constructed. We discussed how you can make your average, how you can calculate average value, that's averaging the concordant values. We talked about volumetric formula. Then we talked about necessary precautions that one needs to take. And then evaluation. Students at home, answer the following questions. What is volumetric analysis? List 5 precautions necessary in an acid-base titration. Why are theta values placed in 2 decimal places? So the candidates can answer these questions. And then for reference purposes, You can consult the textbook of Practical Chemistry for Schools and Colleges by Godwin O. Ojokuku, 4th edition 2012. New School Chemistry for Senior Secondary Schools by Oseiya Akpabio, 6th edition 2015. And Understanding Chemistry for Senior Secondary Schools by Godwin O. Ojokuku. Our next topic is going to be, on this program, is going to be qualitative analysis. Thanks for listening. Join us on WhatsApp on the number 0902 928 2040. Again, 0902 928 2040. Thank you very much for listening.
That was a wonderful presentation by our facilitator. He taught us a whole lot, and I learned as well, so I believe you've learned something this lovely edition of the program, Teaching and Learning on Radio. Well, join us again next time, that's tomorrow. Join us again and for another lovely edition of the program. You never can tell the subjects coming up, so just be on